Welcome to our comprehensive video tutorial on blockchain technology. In this session, we will explore the fundamental concepts that make blockchain a revolutionary technology. From its history to its practical applications, we will cover it all. Let's dive right in. First, let's understand the basic definition of blockchain. Blockchain is a decentralized digital ledger technology that records transactions across many computers in such a way that the registered transactions cannot be altered retroactively. This ensures security, transparency, and integrity. You might wonder why blockchain is often associated with cryptocurrencies like Bitcoin. That's a great question. Let's delve into the relationship. Bitcoin was the first cryptocurrency to utilize blockchain technology, created by an anonymous entity known as Satoshi Nakamoto in 2009. What made Bitcoin revolutionary was its ability to facilitate peer-to-peer transactions without relying on any central authority, which is fundamental to the blockchain structure. Now that we have a basic understanding, let's break down how blockchain works. At its core, a blockchain consists of a chain of blocks, where each block contains a list of transactions. Each block contains three essential components: a hash, the previous block's hash, and the data. The block's hash is a unique identifier generated from the contents of the block using a cryptographic function. It plays a critical role in linking blocks together. In order to visualize how blocks connect, let's implement a simple block structure using Java. What we have here is a class that represents a block with methods to generate its hash. As you can see, we have also implemented a simple blockchain class that manages the chain of blocks. This createGenesis block method adds the very first block into our blockchain. Now, let's discuss the concept of immutability in blockchain. When a block is added to the blockchain, it is extremely difficult to change. In fact, altering any information in a block changes its hash, and that would require recalculating the hashes of all subsequent blocks, making it computationally unfeasible. This feature of immutability is one of the reasons why blockchain is trusted for secure transactions. It creates a trustless environment where every participant can verify transactions without needing a central authority. Next, let's talk about consensus mechanisms. Since blockchain is decentralized, it requires a way for participants to agree on the validity of transactions. The most popular consensus mechanism is proof of work, POW, which Bitcoin uses. In a proof-of-work system, miners compete to solve complex mathematical problems in order to add a new block to the chain. The first miner to solve the problem gets to add the block and is rewarded with cryptocurrency. This process is known as mining. Let's take a look at how we can simulate the mining process in our previously defined blockchain. We will add a mine function to our blockchain class, which will simulate the miners competing to solve a block. This MineBlock method creates a new block with data we provide and links it to the previous block by referencing its hash. This simple method allows us to add new blocks dynamically. Now that we've discussed mining, let's explore different consensus mechanisms such as proof of stake, POS, and delegated proof of stake, DPoS. Unlike POW, POS selects validators based on the number of coins they hold and are willing to stake as collateral. DPoS takes this a step further by allowing stakeholders to vote for delegates who will validate transactions on their behalf, building a more democratic system. This mechanism significantly increases transaction speeds while maintaining decentralization. After understanding how transactions and validation work, let's discuss the applications of blockchain technology beyond cryptocurrencies. Blockchain technology has applications in supply chain management, healthcare, finance, voting systems, and more. Each application utilizes the transparency, security, and traceability that blockchain offers. For example, in supply chain management, a blockchain can provide a transparent record of production, shipment, and delivery while helping to reduce fraud and errors. Each party in the supply chain can track the status of goods in real time. In healthcare, patient data can be stored on a blockchain, allowing for secure sharing of medical records among authorized personnel while maintaining privacy. Each access is logged, ensuring accountability. Let's not forget voting systems. By using blockchain technology, each vote can be securely recorded, making electoral fraud practically impossible. Voters can verify their votes while ensuring their privacy is maintained. We can also explore how smart contracts revolutionize the way we handle agreements. using code to enforce the terms of a contract without human intervention. Smart contracts automatically execute transactions when predefined conditions are met. The smart contract example you see here is a simple contract that allows you to store and retrieve a single number on the Ethereum blockchain. This functionality opens up a world of possibilities in automating agreements. Before concluding, it's important to discuss the challenges and limitations of blockchain technology. Despite its potential, scalability, energy consumption for power systems, and regulatory concerns could pose significant hurdles. To address these challenges, continual advancements in blockchain technologies, like sharding and Layer 2 solutions, are being explored. These approaches aim to enhance scalability and reduce the carbon footprint associated with blockchain mining. As we wrap up this video, remember that blockchain technology is still evolving. Its applications are being explored across various industries, and staying informed is crucial as it may reshape how we handle transactions and data security in the future. Thank you for joining this introduction to blockchain technology. If you found this video useful, don't forget to like, share, and subscribe for more tutorials. We will continue to explore deeper concepts and application scenarios in upcoming videos. Until next time, happy coding!